Hello everybody, my name is Kyle, and today we're going to be talking about how to set up TypeScript and Webpack to work together for a modern kind of like web development stack. The reason why I'm kind of putting together this guide, I'm going to call it, is because when I was trying to figure out how to actually get TypeScript and Webpack to work together, or maybe if I should use like Browsify versus Webpack type of stuff, I was running into an issue where the main problem is whenever I was looking up TypeScript stuff, it was always, this is how you use TypeScript with something like React, or this is how you do just either straight up Webpack, or this is how you do Webpack and React, or Webpack, TypeScript, and React, but it was always like some weird combination, and it's like, I just want to know how I can write TypeScript, use NPM packages, import them in, write my own classes, import all my own files, and then just kind of compile everything down for actual production use. And the system that I've come up with that we'll be covering in this video, although it's not the best, it's not the most optimized, might not even be like the fastest way to compile everything together, but it's a system that works well enough that I've actually used it on production level websites, and I've actually used it now on a few client websites that have actually fully launched, and there's not any issues with it. So it's a solid enough system that it can actually be used for real day-to-day work, and it doesn't really cause any issues. One of the big things about this is you're going to need to know, you don't have to know the ins and outs of something like NPM and Node.js, but you should at least be familiar with it, how to use like either the command prompt, Windows PowerShell, or the terminal to actually run NPM scripts. And that's the way I actually do everything. Is so right now we have this package.json file, we have our script section, and within here is where I define all the different like development things that I'm going to be running for TypeScript compiling and webpacking. And then I also use watch as my task runner. Now, you can use things like Gulp or Grunt, and hell, even Webpack. And I think initially I was using Webpack to do all my task running. But the problem with that is it relies on things like third-party plugins that people have to build and then maintain. And I ran into an issue not too long ago where a package was completely blown apart by the creator. They put out a version that was like 99.99.99, and it was just an empty package at that point, and they completely destroyed what they were working on because of some drama or something. And it had a lot of downloads. It was, I think, a couple million downloads a week, maybe damn near like 5 to 10 million downloads a week. So it was a pretty popular package that was being used, and there were alternatives, and I don't know if people that were using it as a dependency for their package have switched over to the alternatives, but it kind of dawned a light on the situation of that people at the end of the day are still people, whether you're writing open source code or whatever you're doing. People still get egos, people still have drama, people still have problems with each other, and you don't want to tie yourself to this one plugin or one thing that could potentially blow up and then screw over the way that you're doing things. So I try to limit what I'm doing here to the big four, and I also use browser sync, so I guess you could say the big five kind of things. So I'm working with Node Sass, I'm working with Webpack, working with straight up TypeScript, and then I'm using watch for my task running. Now you could use something like Awesome TypeScript Loader or just TS Loader, and I'm sure there's pros and cons to each one of those, and have Webpack actually kind of do invoke the TypeScript compiling, and you could do things that way. But I'm not building any like Vue stuff or any React apps. I'm just working in day-to-day just web development work, client websites, B2B business-to-business websites, or sometimes some like consumer like e-commerce websites. I'm not building these crazy fun like games or React apps or anything like that. So for like the meat and potatoes of it, just like the daily grind of being a web developer, this stack works pretty well. There's some optimization stuff that probably could be fixed up. I took a lot of this from different like Medium articles and just kind of combining everything that I found together and trying to hack together this one thing. So before we jump into actually what the scripts do, and I walk you through my thought process and how I assembled this thing, we're going to talk about the actual folder structure. So this compiled folder gets generated by TypeScript. I have that in my git ignore, so that way that just like your Node modules folder, you shouldn't be putting those onto your actual repository, no matter where you're hosting it. There's no need to. You should be installing Node modules every time you clone the package anyways, and then the compiled stuff, it's not needed. It's just a kind of temporary folder for TypeScript to dump it out to there, and then Webpack can start there and bundle everything up for your actual like production or development compile. I should say bundle. So that's what that is. And then the way I structure things is I have everything under app. You can have a main level folder, or you can put Sass and like the TypeScript folders right on the root directory, but I like to put it under app. And then I have Sass and I have TypeScript. In my Sass, I have the main.scss file. And the only thing that does is it just imports in all the other files. So if you're unfamiliar with like how Node Sass works, you could throw in a new file in here called base.scss. And when you run Node Sass, it's going to actually compile that base into its own file. But if you put an underscore in front of it, it says, hey, this is supposed to be a hidden file. Don't go compiling this into normal CSS. So then what you do is you do underscore base.scss, and then in main, you can just import in that file, and then it kind of branches out from main, and then you just get one nice compiled CSS file. So that's the way that my Node Sass stuff works. I'm not going to get any more into how like Node Sass actually works. That's all you really need to know. The TypeScript stuff gets a little bit more confusing depending on what you want to do with it. If you aren't interested in Webpacking, might not be the best video for you, but I'll still cover the basics of it. You could just have app.ts is what I call it, but I like to think of it as like the main application that runs the website, and then everything else is kind of its own little things. And I'm writing them all as different classes using ECMAScript 6, and I like to import everything into like the main app class and just kind of leave everything in its own little modules, and it takes care of its own business rather than trying to write a massive like main JS file or whatever you want to call it, whether it's like index.js or whatever the naming convention you come up with. I don't want to try to cram all my logic into one file. I want it to be branched off into all these little things. And then eventually, when maybe in the ECMAScript 2019, if dynamic importing for modules becomes a thing, then maybe we could figure out how to work that into the system so that we're dynamically pulling in things instead of trying to load up a massive like app.js file from the beginning. But I want to set up a precedent of like keeping things organized and separate, and everything should handle its own logic, and everything should kind of live on its own island, but then it all comes together to make something beautiful. So I have the app.ts is like the entry point, and then global.d.ts is just your global declaration file. I'm not going to get into declarations because I barely understand them. The documentation is confusing at best for declarations, so I'm not going to attempt to explain how anything works. I've been able to hack together classes and namespaces before for some of my like npm packages, and in order to get them to work, but I have no idea if I'm doing it correctly. And again, I'm very confused on how the actual like global declaration file works. So I have it there because it's useful for some things, like when you have to declare a module for if you're importing like I'm using anime.js as an npm package dependency, and so you have to declare things like this so that you can actually get it to work with your TypeScript and not throw TypeScript errors. But other than declaring modules, I don't know too much more, so we're not going to cover that, at least not in this video. Maybe someday I'll get smart enough and I'll figure it out. Then I have other subfolders like Canvas Manager. This is for a specific project, but it does give a good idea of how I kind of organize things. So like the Canvas folder is gonna be all my Canvas stuff, and then Canvas Manager is like the main manager class, and then that would import like an interactive, maybe like interactive object class, and then I could have like a block class that extends that. I'm not gonna get into how you set up classes and how you then instantiate new classes from that, and then you can have classes that extend other classes and manage all this stuff. That'll be a different video all on its own, just focused on all the ES6 class stuff and how you can kind of think about it and organize it in a way that just kind of makes sense. Other than that, that's pretty much the TypeScript folder. So with the basic directory structure laid out of generating a compiled folder with TypeScript, and then your app, whether it's Sass and TypeScript or whatever, that's pretty much the main things you need to know. So there's a couple ways to think about things when it's coming to running your different tasks and compiling out all your code. The way I look at it is you have dev for development compiling, and then you have compile, which is your like production ready compile, where everything's been compressed and minified and cleaned up. So a few things I'm using for this in my dev dependencies would be npm run all and cross env. So between those two things, as my main like development dependencies, it pretty much lets me run all these different scripts, and we'll walk through them. So if I was to run npm run dev through either the command line, like the CMD window, Windows PowerShell, or my terminal, it's going to run p, which is a npm run all. It means run in parallel. It's going to run watch and then star, which means it's going to run these three scripts right here. So what watch does is you give it a directory to watch. So in this case, it's app/TypeScript. So it's going to watch not only like the main directory, but then all the subfolders within it. And whenever a file is changed, or a file is added, or a file is deleted, it's going to run whatever script you tell it to run. So in my case, npm run dev TypeScript. So then we have dev TypeScript, and it's going to run TSC, which is the TypeScript compiler, and we're also going to run npm run dev Webpack. So when we run dev Webpack, we're using cross env to set up a node environment variable, and we're setting that to dev. And when we get into the actual Webpack config, you'll see where that takes place and why we actually need to do that. But then after that, we're just calling Webpack and we're good to go. So whenever a TypeScript file changes, we run TypeScript, which runs whatever we have set in our tsconfig.json file. It's going to run all that, dump it out to our compiled folder, which is I have set up in here. I'll show you that later. And then once that's run, then we run Webpack. Webpack is also pointed at this compiled folder, and again at the app.js file. And it starts there and kind of branches out, finding all the different imports we need and all the different classes and things that we have set up. And it bundles it all together and dumps it out into our docs, assets, and then app.js. I use docs because it works with GitHub pages. So it's convenient for just kind of maintaining everything on one repository and then being able to link out to people and show off like cool demos, like I'm working on this demo right now. But you would want to point that to whatever your public folder is. The compile pretty much runs the same way, except for TypeScript doesn't also call the Webpack. That's just for the development one. TypeScript is just TypeScript. Webpack compile is Webpack, but it has the production environment variable. And then the node Sass, we just have an output style of compress, so we can kind of shrink down that file size as much as possible. The rest of this stuff, like linting and the test, is just all for kind of sanity checking myself. I use something like Husky with the pre-commit hook to prevent myself from, or anyone on my team really, from committing code that's not been styled correctly or just kind of is inefficient. So those are some other things to look into, but the main thing is you use watch to kind of watch all the files, and then you have it call your dev stuff, which runs like TypeScript compiling to actually compile it down, and then you run Webpack to actually bundle everything up. The Sass thing is pretty much the exact same, except for it calls Sass, and then we don't do anything special because we don't need it to be compressed. So now if we jump into tsconfig.json, this is the way I have this file set up. Now, I've started TypeScript around the launch of 3.0, probably maybe closer to 3.1. I think now it's on 3.3.3, at least at the time of this recording. And these compiler options have changed since at least I've started working with TypeScript. So definitely keep an eye on it. They do deprecate things and change things over time, at least in the few versions that I've seen come out since I've started using it. So this might not be exactly the way that it needs to be set up whenever you're watching this video in the future, but it should give you at least an idea of how to go about thinking about this. So our output directory is obviously the output directory. So I have it going to _compiled. I do the underscore just so it's right up there at the top, and if I ever have to, I can delete it, but I just like to keep it right there at the top. Then our root directory is where it's going to be looking at for all the different TypeScript files. So I point that to app and then /TypeScript, and it's going to grab everything within there and compile it all out to just normal JavaScript. The source map and some of these decorators and all this other stuff and removing comments, a lot of this I've pulled from different Medium articles talking about how to optimize TypeScript to get like the fastest compile times. So at least at the moment, this is some of the recommended things that you can do to try to get better compiles. I don't know exactly why they work. Smarter people than me have figured it out, and I'm just kind of copying and pasting things I've seen in different articles or different people talk about. The other big thing is the target. So I choose to target ES5 because I need to support Internet Explorer 11, at least for right now. And this will change the way that things are actually going to get output. So if you target something as low as like ES3, it's going to look different compared to if you're targeting like ES5 or ES6, or you can go all the way up to ES Next. So the way that this kind of works is if you're targeting something like ES5 in your main application TypeScript file, if you were to write something like .map or like the arrow function, it's going to convert that over to a normal kind of function. If we're just talking about the arrow function, it's going to convert that over to just a normal function call. And so if you switch this from ES5 to ES6, that arrow function, because that's an ES6 thing, will still be there. So you have to use Target to figure out what browsers you're trying to support and thinking about what JavaScript engines are running on those browsers. So I target ES5 so I can support at least Internet Explorer 11. Another thing to consider there is if you're working with something like ES Next or one of these newer ones, it's less of a compile and it's more of a transpile. So if you're compiling down like I am, I'm writing things with like, all the way up to ES Next, so the arrow functions and everything, all the new cool stuff that's been coming out with JavaScript. But then it compiles it down to an earlier version, so it's actually making changes to the code of switching it from the arrow function to the normal function call and stuff like that. But if I was to target like ES Next and I write a bunch of ES Next stuff or a bunch of ES6 stuff, it's not going to actually compile down, it's going to transpile, meaning that all it's doing is it's grabbing the typing stuff. So it's like this like I is a number, it's just going to grab that typing out of there and then just convert it over to normal code, because you don't want that typing stuff on like your actual production server, because it's not going to know what to do with TypeScript. So that's the kind of difference between that. And I just target ES5 because I have to, but I'm looking forward to the day when I can switch that over to ES6. As for the module, there's a couple different things in here. I couldn't find too much information on like the benefits of like the difference between AMD and UMD and then CommonJS. I know CommonJS works for bundling everything together for web, so that's the way I do it. But these other ones might have, different ways to skin the same cat. I don't know exactly what is the best thing to do for your situation, so I definitely suggest looking up the TypeScript documentation there and trying to figure out what module you need to actually work with. But if you're working for web, CommonJS works just fine. For the libraries we're pulling in, we want DOM, and then it's just a bunch of the ECMAScript stuff. And then I'm telling it to exclude the node modules in the compiled folder. Compiled shouldn't run because that's JavaScript, and we're not telling the compiler to actually compile JavaScript files, so it shouldn't matter, but I just have it in there just to be sure. And then as for the node modules, I don't want TypeScript to dig into the node modules folder and try to compile anything in there. So I just say, hey, don't touch any of this. When I need something from there, I will import it in, and then I will let Webpack kind of pull in the JavaScript from that. Speaking of which, at this point is where you have to decide if you want to be working with like a class structure, or if you just want to be writing everything in one file and then just kind of compiling it down to work for earlier versions of JavaScript. So if you're just working in one, you could set like the output directory to be your public facing folder, and your root directory is wherever you're writing stuff. And then you just write everything in one file, and you just pick your target that you need to support, and you dump out the TypeScript, convert it over to JavaScript, and you're good to go. But if you're going to do something a bit more complex and kind of really step up your game to the next level of writing classes and kind of organizing things and starting to get a little bit more complex with what you're trying to do on the web, now we have to jump into the webpack.config.js file. So first thing you have to do is import the path. So we require path, and that's because Webpack forces us to resolve a path to wherever we're going to be outputting the file to. Then we have module that exports. Within here, this is where we use the cross env. So this is something I suggest you definitely use, especially if this is going to be a production-facing kind of like bundle. So for this demo, I really didn't have to use cross env because I don't care if it's all bundled up nicely. I could have just stuck with none, but you might as well for the video show you how you could do production and development bundling all kind of within the same file. So process.env.nodeenv. So that's coming from this. We have cross-env, nodeenv, setting it to production, or we set it to dev. So what it's checking to see is if it's production, and if it is production, we're going to use the production mode for the Webpack bundle. If not, we're going to set it to none. The reason why I set that to none instead of development is two main reasons. First off, I believe the development uses document.write, which according to Google's Lighthouse can be pretty resource intensive and you probably shouldn't use it. And the other reason is because I believe they use eval, and eval does not work on Internet Explorer 11. So when you're trying to test whatever you're working on for the development compile on something that uses like Internet Explorer 11, like a Windows 10 machine, you're going to get errors and your code's not going to run. You might have to try to figure out how to polyfill it, but I didn't want to try to figure out how to polyfill it just so I could test my development code. So I just set this to none and it seems to work just fine. These optimization things, again, I just pulled those from different Medium articles. I have no idea what they actually do or if they're that great, but you know, smarter people than me have figured it out. So I just kind of grab both of those and I use them. The resolve section, this is where you can kind of variant from the way I'm doing things. So again, I like to let Webpack things. I like to let TypeScript compiler compile things. Watch just watches things. So like I use things for what they were intended for, rather than trying to make one thing like Webpack do all the things at once. So instead of having Webpack be in charge of everything, I break it all up into like, you just focus on you and do the job that you were built to do really well. So right now I'm just resolving the JS extension from the entry of my compiled and app.js. Now in here you could be setting up things to use like awesome TypeScript loader, or you could be using TS loader, or I'm sure there's other ones. Those are just the two I know of. And you could actually be pointing this main kind of like app.js file to your main application's TypeScript file, and then it'll handle all the TypeScript compiling, and then it'll also Webpack all in one go. And you can use different like plugins to do like CSS stuff. Initially I was doing that, like I said, but I've switched over to this method of like just letting the big boys handle what they're supposed to handle, and then I just use my npm scripts to kind of manage and get everything to play nicely together, rather than forcing Webpack to kind of like be my task runner and do everything itself. So we have our entry, we're pointing it to app. So the way this kind of works is you can think of it like the way you can think of bundling is we're pointing to one specific file, and it hits that file and it sees all these different imports up at the top. So it's like, oh, I need to import Canvas Manager from here. So then it branches out to there and grabs that package and kind of like sucks it in. And then, you know, if we had more importing from like the node modules folder, like if we were pulling in anime.js, then it would go over there and grab that and kind of pull it in and bundle it all up. So you point it at one file, and then it kind of branches out and picks up everything and sucks it all in. And then for our output, I'm just dumping into the docs assets folder, and I'm just calling it app.js. So now we'll jump into app.js or app.ts. So this is kind of the basic way I set up my basic like application class. Again, I like to think of these as like kind of web app type things, the way that I'm running the JavaScript on these websites. So export default class app, and then this is my import for my Canvas Manager. And again, this is going to be for a later tutorial where I start talking through like how classes work, how you can set things, calling super, extending other classes. So we'll dive more into this kind of class structure and the ES6 stuff later. The main thing is you have the main application class. We have a constructor. In here, I'm instantiating a new version or a new copy of this Canvas Manager. And then down below, we have an immediately invoked function expression. And all that does is it just calls app on the load of everything. And then this is what kind of kicks off everything for our application class. So to see what it looks like when you actually compile this down and bundle it all together, a bunch of this crap at the top is all just kind of like the Webpack bootstrap stuff, so you don't have to worry about it. But if we look at the actual JavaScript, you can see that we have like var Canvas Manager, it's a function, and then it has all this other stuff within it. So this kind of shows how we're switching things over from like, oh, this is no longer a class because classes don't exist within ES5, so we have to switch this over to a function. However, if we were to switch this over to ES6, and then within here, we were to run dev TypeScript. So it's going to run TypeScript and run our Webpack, and it'll let us know when that's done. All right. So now if we head back into app.js, you can see now we're doing class, Canvas Manager, and constructor because all this stuff is supported within ES6. And I'm not up to date on exactly what browsers are on what JavaScript engines. I'm assuming this would probably work on things like Chrome, but I don't actually know, and I need to support some of the older browsers. So again, I keep this on at least ES5. I probably wouldn't ever go back as far as ES3, but if you have to support something like Internet Explorer 6, you know, Godspeed. So that's pretty much the basis of the way I do things with the development, compiling, and the dev stack, and then the compile version, and then just using watch to watch things. If you have any questions, or if I did anything wrong, or there's better ways to do what I'm doing right here, please feel free to let me know. I would love to learn. Again, this is probably about maybe 6 hours of me browsing around, trying to figure out how TypeScript works and how Webpack works, and reading through the documentation for both the compilers and the bundlers, and trying to figure out how to like merge them together, not to build some crazy like React app, or to build the next like, I don't know, anything. I was just looking for something that is sturdy enough to actually use on like public client-facing projects that I can use in my day-to-day work life, and not have to worry too much about some little plugin over here or something breaking over here. If something like Node Sass goes away tomorrow, I'm not the only person that's going to be up shit creek. There's going to be a lot of people scrambling to try to figure out how we can replace this or fix this. So I try to stick to the big ones, and I don't really mind the few extra 100 milliseconds that I lose because I'm running TypeScript compiler natively, rather than trying to use like an awesome TypeScript loader within Webpack. So again, if you have any suggestions on ways that I can make these videos better, or any ways that I could adjust this kind of like workflow to be faster or just more optimized, please do let me know. I would really appreciate it. Thanks.